If you've ever tried to learn deep learning, you probably know the feeling. You're just swimming in this ocean of tutorials, all this hype, and honestly, it's just overwhelming. Well, today we're going to cut right through all that noise. We are laying out the exact roadmap to take you from someone who just runs code to someone who can truly architect intelligent systems. So, does this sound familiar? You're stuck in what people call tutorial hell. Yeah, you can follow a guide, you can run a script someone else wrote, but you don't really get what's happening under the hood. This makes you a consumer of code, not a creator. It's a super frustrating place to be, and it's probably the single biggest thing holding people back from making real progress. So that really is the big question, isn't it? How do you make that leap? How do you go from just consuming code to actually being an architect who can build systems that work in the real world? That is exactly what this explainer is all about. This is your path forward. All right, so phase one is all about getting your mindset right. We have to escape that tutorial trap. And the way we do that is by defining what our real goal is. It's not just about coding. It's about a much, much deeper understanding. This is so important. We have to shift our focus away from all the superficial stuff. Your goal is really twofold. First, it's to master what's called deep representation learning. That's how AI actually understands data. And second, it's to get really good at deploying these systems. If you can master both of those things, you're building the foundation to become a real architect. Okay, on to phase two. Now, before we can even touch all the exciting new models, we have to build a solid foundation. You know, you can't build a skyscraper on sand, right? And you definitely can't build powerful AI without understanding the math. This is your first big challenge, but it's one you can absolutely conquer. These are the 4 big pillars. You need an intuitive feel for each one. Multidimensional calculus is how models actually improve themselves. Linear algebra is all about how data is structured. Probability helps you handle all the uncertainty in the world. And optimization theory, that's what makes the whole thing learn. Seriously, there are no shortcuts here. You gotta know this stuff. So how do you actually tackle this? Well, not by just passively watching a bunch of lectures. You've got to use a flipped classroom strategy. First, read the core theorems yourself. Then, and this is the most important part, you try to code the algorithms from scratch. It's going to be hard, I promise, but when you hit that wall, that's when you take your specific problem to a study group or an online forum. That active recall, that's how you really learn it for good. All right, once you've got that solid math foundation locked in, now we get to enter the world of modern AI. And this is where things get really, really exciting. We're going to focus only on the architectures that are going to define this field in 2026 and beyond. We have to be really strategic here. Forget the legacy systems. Your energy, your focus, it needs to be on the modern toolkit. That means mastering transformers, the architecture behind things like ChatGPT. It means understanding diffusion models, which power all those incredible AI art generators. And it means exploring deep generative models. This is the absolute state of the art. At the very heart of all these modern systems is this idea of deep representation learning. It's basically how models learn to represent really complex data, like an image or a whole paragraph, in a compressed, meaningful way. They do this by creating something called a latent space, which is kind of like an abstract map of concepts. This is where the real magic happens. So now we've got the theory. We understand the maths, we know the modern architectures, but theory by itself isn't enough. Not even close. The final phase is the ultimate test, taking everything you've learned and putting it into practice by building something real, something substantial. This quote just says it all, doesn't it? If you can't actually apply what you know, it's just trivia. A portfolio that's just a bunch of copy-pasted notebooks from tutorials, that's not going to cut it. You need to prove you can build a complete end-to-end system, all the way from the ground up. So what does a masterpiece project actually look like? Well, it's a full life cycle, just like you see here. You start with a huge open source model. Then you optimize it. You use techniques like quantization to make it way faster. Next, you build out a full MLOps pipeline to handle the data automatically. And finally, you actually deploy it to a server or maybe an edge device. When you can do all of this, you've made it. And there you have it. That's the complete roadmap, from the foundational math all the way to a deployed, portfolio-worthy project. Now, let's put a little bit of a time frame on this whole journey. This entire journey from learning the math to deploying your final project, it's achievable in 6 months. Now, it's going to require discipline for sure, but it's a concrete goal. Don't think of this as some endless quest. Think of it as a syllabus for the next half year of your life. And just remember this whole thing requires rigorous study and a real commitment to actually building things. There are going to be tough moments, especially with the math and the deployment phases. But it's consistency that's going to get you to the finish line. It's all about that sustained effort over time. So the only question left is, where are you on this map? Are you just starting out with that mathematical foundation? Are you in the middle, trying to master the modern architectures? Or are you ready to build your masterpiece? The journey starts with a single step. Which one is going to be yours?